back to an episode of the Open Source Cafe, and today we're talking about reliability at startups. So we have Eran joining us from Twingate, and we have some nice questions for Eran because when we're talking about startups, some big tech companies, they have like the bandwidth of like thousands and thousands of people. They have dedicated teams for everything, reliability including. But for some startups, they're like, okay, we have just like 10 people, just like 15 people, 20 people. So oftentimes you're like, okay, how do you make sure you're maintaining reliability? So we have Iran joining us, who is the director of engineering at Twingate. And before we get started, and would you like to tell our viewers a little bit more about yourself and what got you involved in your current startup, which is Twingate, and what you're doing before that, and what made you decide to move over to Twingate, and how's the whole journey been?
Sure, thank you. So, hi, my name is Eran. I'm Director of Engineering at Twingate. I've been doing software engineering as an IC and a manager for over 20 years now. Did a bunch of startups before. I founded Monday.com when I was in Israel. So been at big companies, small startups for a lot of time. And before we talk about Twingate and why I joined it, let's just do like a brief, in a sentence, what Twingate is, right? So Twingate is like VPN, but different. We allow you to implement access to remote resources in different networks that are not your own securely without making it painful like VPN does. And the reason I found it interesting and I joined Twingate, I'm actually at Twingate from day one. We have like quite a big founding team. It's a boring problem, right? No one thinks about, like if I tell you tomorrow, let's go start our own VPN, doesn't sound interesting, right? No one thinks about it. And because no one really thinks about it, it's not like a cool, sexy new AI problem. There's a lot of opportunity there to do something different, right? Because all the companies, they pretty much do the same VPN with some, more feature, less features, but the same old thing, the same approach. And it's a really interesting opportunity to take a different approach and try to solve that same problem from, look at it differently, solve it differently, and really change something in a flow that is being used like in almost any tech company or any company that I've been in, right? So it's a very common flow. It's not like we're inventing something new. And not only that, so the product and the new approach is interesting. There's also an interesting DevOps challenge here, right? Because keeping a service like this up and running with reliably is a very interesting technical challenge. I can share that we handle over 1 billion connections every month today. We need to be up 24/7, very high, like 4 nines reliability standard, because basically we're the network infrastructure for our customers. So if we're down, they don't have a network, and they can't work. So we're like a utility company. We need to stay up.
I didn't know you worked at that you founded Monday.com. It's pretty cool.
Yes, thank you.
I use it every day.
You use it, nice.
For me, that's the main tool that we use. But want to follow up on you mentioned 1 billion connections every month. Now that's a lot. How are you able to handle that? So can you maybe share some insights into like the scale and complexity of your infrastructure that is allowing you to do this?
Yes. So infrastructure and the complexity is something we grow with, right? So we had our own, I guess like any startup, at some point we had our own like a crisis moment when we realized we have to make a change to be more reliable. We had a couple of downtimes and we figured out we need to change something. So to get to our philosophy, let's first cover like the main two issues for reliability issues. The way we see them is The first one is self-inflicted, like you have a bug, you deploy a bug to production, there's a downtime, it affects reliability. And the second one is infrastructure, right? So sometimes we use Google, we use GCP. Google has a bug, Google has a region down, and it causes disruption in the service. And the worst kind of reliability issues is both. So for example, we implemented retry logic in our clients, and Google load balancers were down. So they were down for like an hour or so. And when they went back up, all the clients were retrying at the same time, and we had a thundering herd problem. Basically, we took our clients, spammed their own servers, and took us down. So those are the two main categories of reliability problems. And we implemented all sorts of processes to tackle both of them. I think if we look at it, first from a philosophical perspective, our engineering philosophy is that engineers need to own their features end to end. So they take part from the planning phase, writing the technical spec, to actually writing the code, reviewing the code, and actually deploying it to production and monitoring it, right? So it's not like bigger companies or other kind of companies where you have developers, they write the code, then they send it to QA, QA need to test it, then they send it to production, some team deploys it, there's another ops team that is in charge of monitoring it. If there's a CI problem, there's a CI team. No, so in the way we see it, to get to the quality that we aim for, engineering team needs to own the feature end to end, from development to operating and monitoring it. And we provide all sorts of tools to support that flow. Everything has to be automated, right? So we have, actually no one has permission to our production environment, right? A lot of companies, sometimes you do like manual stuff in production, and we don't give permissions to anyone to our production service. Even I don't have permissions, right? So, and it brings the kind of thinking that everything has to be automated, everything has to be tested. Because once you open up that window of, let's do this small thing manually, it opens up a window, and things start to happen manually and unsupervised more often. So we never open that window. So automation is the first part. Unit tests, CI, integration tests, smoke tests, provisioning of new services or new servers or databases. Everything is automated with Terraform or with Helm charts. We use Kubernetes, and nothing is done manually. Database migrations, all that stuff. And the second component is we really treat reliability as a feature. In every feature, in every technical spec that we write, in every feature that we plan, reliability is taken into account. How do we make this feature reliable? How do we monitor it? How do we operate it and make sure that it doesn't affect the system negatively? And to do all of that, we also provide engineering with infrastructure to be able to do all that. So for example, since everything is automated and everything is source controlled, we use Prometheus, for example, Prometheus operator, Grafana operator. So even alerts and dashboards are in source control. So when you deliver a feature, you PR a feature, the way to monitor it, the metrics are in the code. The alerts are also in the code in form of Prometheus rules that are Prometheus operator syncs to Prometheus. And even the dashboards to monitor the tool are there as part of the code, as part of the PR. Another thing we do is feature toggles. So every major feature that goes out needs to go out with a feature toggle so that we can gradually roll it out by customer, by user, and we gradually roll it out to our entire user base, measure it to make sure it works properly and it doesn't affect negatively the system. Yeah, so we have a lot of guard points throughout the way to make sure everything is reliable.
You're using feature flags as well.
Oh,
Very
yeah.
nice. So how does your engineering philosophy fit into that? Like, because we're talking about maintaining reliability, what are some of the key considerations you have and like within your team? Like, okay, if you're talking about maintaining all the uptime, for example, uh, and you know, engineers on calls and things like that. So how do you have that built in within your company and like sort of like in your values?
Yeah, so because engineer, so when there's a problem with the feature, who's the best guy to know how to debug it? It's the feature owner, right? So we have an on-call team, right? And basically it's all the engineers. We do rotations. Since we're a distributed company, we have people all over in all time zones, so it's easy to do like on-call rotations. So all the engineers do on-call rotations. They know the system mostly throughout like all the different sections. Of course, they know their part better, but if something happens and it's not on their part, they know who to call. So everyone does on-call duty. And also, the main thing is about planning. When we plan features, we have like a technical spec template, and we include reliability stuff that you have to, we want to make sure that you think about when you plan the features. So the main example is feature flag. Does this feature require a feature flag? Yes, no. If yes, what's the rollout plan for it? Do you want to roll it out by customer? Do you want to roll it out by user? What's the percentage? What are you going to measure on each rollout step to make sure that you can go ahead with the next phase? If you're calling different services, right? So different services interact. How do you handle yourself if that service is down, right? So if one service has a problem, you don't want it to start a cascading effect of all its dependencies going down too, right? So if each service has to have some default behavior so it can remain up even if another service that it depends on is down. All sorts of stuff like that. But we didn't talk operatively, how do we handle reliability? So we do a lot of stuff in DevOps that you normally wouldn't see in a startup our age or size. We run multiple Kubernetes clusters across multiple regions, active. So for example, in the US, we have a cluster in East, Central, and West, and they're all active. If we see an issue, for whatever reason in any region, we can automatically shut it off, move all the traffic to other regions so we can debug. So cloud providers don't usually have big major issues you read about in the news, but they have like these small ticks, like sometimes load balancing or networking doesn't work in a specific region. And being active in 3 regions gives us the flexibility. As soon as we see something odd is going on in a certain region or a zone, we immediately move all the traffic away so it doesn't affect customers, and then we can debug it, and we can even gradually move traffic back. So it's not all or nothing. Yeah, which is pretty
Yeah,
cool.
and like with providers, we have seen like they are not uh, safe from like outages either. Like with the hyperscalers and stuff, we've always seen like okay, some of them have outages and all those things. But okay, thanks for sharing. There's a lot of tips, and especially for people who are looking to have high reliability. But let's talk a
Mhm.
bit about Twingate. And when you go to Twingate, the website says time to ditch your VPNs. Why are you trying to ditch VPNs?
So I think it's an obvious question, right? I haven't met anyone who I asked about their corporate VPN and if they like it, and they really liked it, right? Everyone, it's a pain that you have to endure in order to do stuff, and we want to make it not be a pain, right? So what's the problem currently with VPN? So Let's divide it into 3 parts. Let's start with the end user. Whenever you connect to a VPN, it basically takes over all your traffic. So let's say you want to connect to your company's remote Jira server, right? So you connect to VPN, you can access Jira, but now it takes over all your traffic. If you go to YouTube, suddenly it's slow because all the traffic flows through your company's server, which could be in like a different country. Like I remember when I worked at SAP, I would connect to the VPN, suddenly my Google results are in German, right? And I don't read German and I have to, hack around. And what happens to users is that it becomes frustrating. You always have to be aware, am I on VPN or not? I need to do something with a remote server like Jira. I will connect my VPN, do whatever I need, and disconnect so I can continue doing my other stuff. And that's frustrating, and we want to solve that. For the companies, owning and maintaining VPN is costly. It requires its own dedicated server to be able to handle all the traffic from all the employees that use it. And it requires a special setup because the way of how VPNs work, VPNs basically connect networks. So you set up a VPN, it's a public server with a public IP so that users could connect to it. And since it's a public endpoint, you have to protect it. You have to keep it up to date. A lot of the hacks we read about in the news are just usually someone forgot a VPN server somewhere open to the internet and didn't update to the latest hotfix. And the hacker with a simple port scanner found it and used a known vulnerability to get in. So you have to protect those constantly. And also because companies usually have more than one network to access to, right? You have your, if you're a cloud company, and at least you have like a non-production network and a production network. Usually you also have an office. And because of the way VPN works, you need to take all these networks and make them one in order for the VPN to provide access to them. So you need to do all sorts of peering, and basically you need a PhD in networking to set that whole thing up and keep it working, which is expensive. And the last reason VPNs suck is that they're not even secure, right? So what a VPN does is just take your network or your laptop and puts it in a remote network. So now you can access everything in that network. And that's not really secure because the perimeter of what you should be able to access should depend on who you are, what device you're on, and not which router you're connected to, right? So we should give you access to Jira because you're an engineer and you need access to Jira, not because you managed to connect to the right router. And those are the 3 problems we aim to solve with Twingate.
Thanks for sharing. And one of the reasons I've seen like folks using VPN is to give them like least privilege access as well, maintaining that zero trust, for example. And yeah, oftentimes it can get a bit challenging. And I have seen this myself because some employees who, let's say, might not be that technical, and then they're like, "Hey, I'm having some VPN issues. Can you help me?" And I've seen that happen. So when you talk about zero network, zero trust security model, how does Twingate help organizations in achieving that?
Yeah, so basically the way we're different than VPN is we don't have a central server that, or even a public server. We give you this Docker component we call the connector, and we just tell you every network that you want to start configuring access to, just run this Docker in that network, right? That Docker runs in the network. It makes calls to the outside. It doesn't, receive incoming calls. So it doesn't need a public IP. You don't need the complex firewall settings. And since you can run it in each independent network, let's say you have 4 networks, just run it 4 times in each network. You don't need to handle like peering and all sorts of that, complex network configurations. And that saves the second problem I mentioned earlier of cost of ownership for companies, right? It's really easy. You just take the Docker, run it in every network, and you can start configuring who can access what. You don't need to do complex configurations, monitor it, keep it up to date. It's invisible to hackers because there's no public IP. So that solves that problem. The way we solve it for users is that we're split tunnel by default. So unlike VPN that takes over all your traffic, we know to differentiate between which traffic we need to send to your secure network. Or in the example we gave earlier, when you try to access Jira, it will go through Twingate. But if in parallel you're watching a video on YouTube or playing some music from Spotify, it will go through your network. So it doesn't, when you connect to Twingate, it doesn't affect all the other stuff. So you don't mind keeping it up all the time. You don't need to be frustrated. You don't need to be, connecting, disconnecting all the time. You just keep it up all the time and not have to think about it. And it solves that frustration problems users have with VPN. And lastly, regarding the zero trust part, basically what Twingate does is once you run that Docker in the network, it doesn't mean that anyone that connects to Twingate can access anything in that network. It means that you can configure who can access what in that network based on policies. And we allow you to define policies that are based on, the user, the role of the user, and the device the user is on. So you can say stuff like, all engineers should be able to access Jira, but marketing folks, they shouldn't be able to access it. So if you're a marketing person and you connect to Twingate, you won't even see that Jira exists. It won't exist for you because your network perimeter will not include it. You could say stuff like if an engineer wants to access Jira from a company device, all he needs to do is authenticate, so we make sure he's, who he is. But if he's accessing from a personal device or non-company laptop, we require extra authentication. He also needs to go through MFA, for example. Yeah, and that's how we solve the zero trust problem.
Amazing. Well, thanks for sharing, Iran. Learning a lot from you. And mention about DevOps and IT teams. So, uh, can you give an example? How those folks are using Twingate right now, and you don't have to name any like customers or anything, but just like an example of how folks in the DevOps and IT teams are utilizing it.
Sure. So one of the things we saw that helps companies adopt zero trust the most is we want to hook into their existing workflows, right? So companies already today, their DevOps teams use automations to set up the infrastructure. So maybe they use Terraform or Pulumi or Cloud. I forgot the Amazon framework name, like CloudFormation. But the point is that these teams already have existing automation flows of how to set up their infrastructures, and we want to hook into those flows. So the first thing we did, we have everything that you can do in our UI, you can also do via an API, and we have a very nice GraphQL API, self-documented. You can look at the open graphical, look at the schema, and very easily figure out how to do stuff and write your own scripts. But we also provide, for example, Terraform provider. We have our own Terraform provider. So if you use Terraform to provision your infrastructure, you can use the Twingate Terraform provider to also provision access to that infrastructure in the same flow. So you set up a new server, for example, in Terraform, you can define how to access it, what the policies to access it in that same flow. It allows teams to move faster in adopting ZTNA because it hooks into their existing flows. And since all that stuff is also usually source controlled, it allows them to audit permission easily. So you can see when that server was set up, when was the access to it defined, who defined it, when was it changed, because it's in your Git log. Another way we see DevOps use and IT teams use our product is with CI automations. So when you have zero trust for users, So it's not only users that need to access secure stuff in different networks, it's also processes. So for example, your CI process might need to deploy new software to a remote server in a production network, and you want to let your CI step access that network. And one of the things we have is besides having Mac, iOS, Windows clients, we also have a headless client that you can run as part of your CI job. So you can have a GitHub action that connects, that runs the headless client in the background, which allows it to connect to a remote cluster in your production cloud environment and deploy stuff to it. So GitHub Action, Circle CI, Jenkins, and whatnot. You can put. We also allow you to do zero trust for your processes, not just for your users. And one of the coolest things I see that even we use internally, but I see other teams use, is allowing you to very easily expose internal services to your users. So I'll give an example of Grafana, right? So we have a Kubernetes cluster and it runs Grafana. And before Twingate, in order to allow our other engineers to access that Grafana and use it, because Kubernetes is in its own private network no one has access to, it would require a significant amount of work, right? So obviously you can do it the ugly way and let them do port mapping to the cluster, and then they can access the internal service on their machine. But that's hard, annoying, and usually you don't want to even expose that to developers because it's a security risk. So what you would have to do before is like set up an internal load balancer, expose it to the VPN, do all sorts of stuff to expose it. With Twingate, when you have a connector running on the cluster, all you have to do is define the internal endpoint in the cluster. So let's say grafana.default.cluster.local, define it as a resource, and you can start exposing it to users, and they'll be able to access it securely, and it takes like 1 minute to do, no work. And you can even do like cool stuff like require MFA to access Grafana. And Grafana is a good example, right? Because Grafana also has its own authentication. It has users and permissions. So if you access Grafana, you need to log in. But think about other services that are like maybe a simple web page, that like Prometheus, right? Prometheus doesn't have users and authentication. So how do you protect it? With Twingate, you can expose the Prometheus internal endpoint and require authentication to access it, and require MFA even to access it, and make sure that only people on company devices can access it. And that's really cool. It allows you to expose like internal interfaces in your clusters that are used for engineering to debug stuff or to view stuff easily without too much work and without having your CISO go crazy.
Amazing. Well, thanks for sharing, Iran, and really learned a lot from you. And thanks for answering all my questions. And I believe the tips you shared will be helpful for other folks and who are looking to build their own, scale their own startups. And lastly, I'd like to ask just a wrap-up question, which is if folks want to get involved with Twingate like today, where can you point them to? And I'll update all the links in the description below as well.
So I would just point them to twingate.com. So Twingate is self-serve. We strongly believe that of not putting our product behind like a demo wall or a sales wall. We want to build a product that's simple and self-serve so that people can sign up, play with it, and use it right away without needing like special guidance, even though that's available on request, right, if you need it. And we also have a free tier, forever free starter tier that should be good enough for any home user to use with their home labs. So you could just go to twingate.com, sign up. You'll get a starter tier account that lets you do pretty much most of the things you'd want to do. And you can start playing with it in your home lab environment. So if you have like a, I don't know, NAS server at home and you want to be able to access those files and photos remotely when you travel, You can easily set that up. You just need to take that Docker I mentioned earlier, run it somewhere in your network. Usually those NAS devices even support running their own Dockers, right? If you use like Synology or something, you can run our connector on your Synology, and then you can access it remotely when you travel, when and you can give friends access. Twingate even support ephemeral access. So, you want to give someone access, but make it temporary, like for 1 hour, you can do that. Yeah, so go to twingate.com, sign up, play with it, and we hope you like it.
Amazing, thanks, Eran. And we'll be doing more such sessions as well. I'm happy to play around with it. I saw it's like reasonably priced as well, $5 per user, which is nice. And you mentioned your free tier as well, so highly recommend trying that out. Leave the links in the description below. But thanks for joining, Eran. Really appreciate you giving your time
Thank
and
you.
knowledge. And yeah, see you next one. Bye.
Bye.